to look at gives us the piecewise function g of x. G of x has two pieces to it. It has the x plus 3, which is a linear function, and that domain is x is less than 0, and it has the absolute value of x minus 2, and that domain is defined between 1 and negative 8. So we see these two pieces on the graph. We see my linear piece, and it's everything less than 0, so it goes on forever in that direction. And then we see our absolute value piece, which is going to be between 1 and 8. So we can use this information to evaluate the following. So if I want to evaluate g of negative 5, first I need to decide what domain does negative 5 fit into. Is negative 5 between 1 and 8? No. Is negative 5 less than 0? Yes. So I know that I'm going to be looking at the linear part of my piecewise function. Now there's two ways that we can do this. The first way that we can do it is just by looking at the equation. I know that I'm trying to define it at negative 5, so I can replace the x with negative 5 and just plug it into my equation. Negative 5 plus 3 equals negative 2. Now today we're going to be focused mainly on evaluating it using the graph. We're going to look at the equation a little bit more next time, but I want us to focus on the graph today. So if I go to negative 5 on the graph and then go down to where it hits my function, I see it's also at negative 2. So either of those methods work. I wanted you to be exposed to both of them, but today I want to look mainly at the graph. So let's look at 0. What domain does 0 fit into? Is 0 between 1 and 8? No. Is 0 less than 0? No. So notice that this is x is less than 0, not x is less than or equal to 0. So x is not defined at 0, and we can also see this by my open dot here. So since I have an open dot, that means that x is actually undefined at 0. Let's look at the next one. G of 1. Is 1 between 1 and 8? In this case, yes, because I have x is greater than or equal to 1, or 1 is less than or equal to x, meaning the 1 is defined here. I can also see that because I have an open circle, a closed circle at 1. That means it's defined. So if I go to the x value 1 and go up, I see I'm at 1 on the y value, so that's my answer. I can also evaluate g of 2. So 2 is going to fall again in this domain between 1 and 8. So if I look at 2, it's actually going to be at 0. It's going to be the vertex of that absolute value function. And then if we go to g of 8, if I go all the way to 8 and go up, notice that this is again an open circle and a less than value, meaning 8 is not included, so we are undefined at g of 8. Over with you guys for today is if I give you the graph of a piecewise function, can you give me the equation that models it? So let's look at just the graph first. There's 3 pieces to this piecewise function. I have this blue piece right here, which is a linear function, and we'll see that its endpoints are negative 12 and negative 4. It's defined at negative 12. It's not defined at negative 4. And we also see this red graph right here. This has a slope of 0, meaning it's just going to be y equals a number. It's defined at both of its endpoints, negative 4 and 2. So although the blue part of the graph, the linear part, was not defined at negative 4, the red one was. So this defined point kind of plugs the hole of this one right here. And then we have a quadratic. So it's defined at this endpoint, which is 7, 5, so my x value here is 7, but it's not defined at this endpoint, which is 2, 10. But remember, this endpoint is defined, so it kind of plugs that hole. So if I give you this graph, would we be able to write a function of each of its 3 pieces? So let's look at that. Let's first write the domain. We'll think of it that way. So the domain of the blue portion of the graph goes from negative 12 to negative 4. So I know that I have a negative 12 and a negative 4. Is it defined at negative 12? Yeah, we got a closed circle, so that's going to be less than or equal to. Is it defined at negative 4? No, so we're going to leave that just as a less than. What about this one? My domain here goes from negative 4 and it ends at positive 2. Both of these are closed circles, so both of these are going to have a line underneath to signify that they're included. And then this graph is going to go from positive 2 to positive 7. This point is undefined, so we're going to leave it as just a less than. This point is closed, meaning it is defined, so we're going to make it a less than or equal to. Now let's write our equations for each one. We'll start with the green graph. We know that this is an x squared, but it's not just any x squared, it had a shift. Instead of being centered at 0, 0, it's centered at the point 5, 1. So this graph is actually going to be defined by, if I have a horizontal shift 5, I'm going to say x minus 5 squared, and I went up 1. So that would be my function. This one is just a horizontal line going through 5, so it's just y equals 5. And then this is a linear function, so I need a slope and a y-intercept. So my slope, let's say we start here, we go up 1 over 2, up 1 over 2. So I know that that's going to be a slope of 1/2. And let's keep that slope going to see if we can get a y-intercept. So up 1 over 2, up 1 over 2, up 1 over 2. My y-intercept, if we didn't have the restrictions of the domain, would be 5. So if I want to write this as one united piecewise function, I would say f of x equals. Now there's 3 equations that I need to include here. So let's start by writing this one. I have y, oops, we don't have to write y if I already have the f of x. So I'm just going to say 1/2 x plus 5. And I need to include my domain. So some people put a little colon, or a semicolon. Some people will say if x is between whatever. We're just going to use the semicolon. So negative 12 is less than or equal to x is less than negative 4. So that's my first graph. My second one is just y equals 5. So all you have to do is put a 5, put your semicolon, and that is going to be between 4 and 2. So we got that one. And then the last one is the quadratic. You can put these in any order, it really doesn't matter. And that domain is defined between 2, positive 2, and this right here is my piecewise function that matches the graph.